bullets,
Hmm.
but kind of I'm not sure how I can make it better. Like split it into there are two ways. I can either show each sentence on addition, like on a new slide with a background, but it's just time and like switching off too often.
Hmm.
There is another way. I can keep all the bullets but change backgrounds, highlighting just one row every time I talk about it, or I can just keep it as is.
Yeah,
Maybe.
I like the second thing you said, or you can just introduce them one by one. I think you run into the risk of people. I do this a lot as an attendee. I lose attention because I concentrate on reading and then I don't listen to what you say. But if you present point by point, like at the beginning you only see the first one, then you introduce the second and then the third one.
Yeah,
That
okay.
way,
I can do that. Yeah.
or but what you said, the second thing that you said is basically the same thing. You just highlight it instead of hiding it by yeah.
Yeah, yeah. Just I want them to concentrate on the one I'm talking about, but I
Yeah,
don't want them to lose the history of what I
yeah,
said before.
yeah.
So maybe it's gonna be like separate slides with just the previous one grade. But it just takes time to build that. Then another slide about metrics. Again, just few practical things to watch for on introducing metrics. But if you remember that I wanted to kind of to focus the talk more about the tracing. So it's going to be a bit more slides about tracing. So why we need that, so the benefits and things we can investigate with tracing. Again, this is kind of a continuation. So this explains all the things. Then there is a diagram here, and I'm going to talk about what I can investigate using the diagram. Then there is a deep dive. This is Lightstep into what Lightstep offers, and again, what you can see here. So all the logs, latency things, tracks, whatever.
Mm-hmm.
Then I'm going to talk about like doing these across multiple transports and how like do not just HTTP matters.
Mm-hmm.
And then just it's kind of a wrap up. So that's what I achieved overall.
Cool.
That's overall lessons learned. And again, I'm going to talk here quite a lot. So these are just really small bullets. So there is quite a lot of things to talk about here, and traditional one. That's it.
Cool. That makes sense. So, what do you want to do next? Do you want to do do you want to work a bit more on the presentation and present it to me another time, or you want to do it now? Like I'm available if you want to do it. Like we still have like a couple of weeks, right? So if you want to spend some more time
do you feel there is really something I need to work on in terms of presentation itself? Because I see only visual, like how I visually present it rather than what I talk about. I mean, we can have another call like later, or I can just drop you a deck if you want.
It's entirely up to you.
I mean, let's do a dry run, because if there is something like totally wrong with what I say and how I say it, I'd rather get it earlier so I can actually change that.
Yeah, I think that's very unlikely, but yeah, sure. If you want to do that, we can do that now. And then maybe another time as well if you prefer. It's entirely up to you.
Let's do now if you have time.
Okay.
Are we talking about half an hour top? Yeah.
Yes, ideally anything from 25 to 35 is fine. Anything shorter or longer is a bit of a problem.
Yeah, because it messes up the schedule. Yeah, I get it.
Yeah.
Okay, let's try. Hi, I'm Igor, and I'm principal engineer at Skyscanner, and I want to talk to you about adopting observability at scale. In my, it's now like 13 years of career, I've been an engineer to CTO at different digital consultancies and telecom companies back in Russia, where I'm from. And since I moved to the UK in 2014, I've been head of engineering for a fintech company called Currency Solutions. And last year I started at Skyscanner where I'm a principal engineer. A few fun facts. I'm not sure actually if I want to read them. I can read them. So a few fun facts you may want to know about me is that I set up my first public Linux server when I was 13. That did run a public website written in PHP 3, I think, and the Quake 2 server, which we had a lot of fun with. I did have a 19-inch rack in my flat in Russia. It was like a purpose-built cupboard running all the home automation. And I'm still listed as a technical content for IPv4 autonomous system on the internet with a few hundred IP addresses, which are quite rare at the moment. And what I want to start with is the beginning. And the beginning, most of us in our engineering career had a monolith. And that monolith was usually some big black box where nobody knew what it is about, what it's doing. And we really sometimes didn't want to investigate that. But it did blow up from time to time. And when it did, well, the only logical thing we did when we were really not aware of how to do it better was we went and read logs we had. And it took time. It wasn't really an efficient process, especially when you have a large system and especially when it was not written by only you. But, well, that's how it worked. So now it's 2019. We all talk about having microservices, and imagine we have 5. So what happens if one of those blows up? Well, most of us will still go and check logs, but what if that's 2 services? Well, can you actually keep up and read logs that fast? But imagine if it's 50 services. Well, it's just going to blow up the whole system and the whole business. So what I want to talk about to you today is observability, which is a way for us to combine metrics, logs, and distributed tracing into one single system, which will work in, I forgot the word, which will work in, okay, let's go together. I will find the right word to solve the problem of us looking at a distributed system at scale. But let me come back to where I started. So back in 2015, I moved to the UK and I was given this nice legacy system, which was, well, essentially this. It was a large black box which did something. So that black box had a login platform, which was, well, by idea, not that bad. It did have structured login, so it did produce log messages in JSON, but sometimes it did not, and it produced some of those logs in plain text. The worst part about that it was sending those log lines to a service called log entries, and it was sending them on synchronous TCP connections, meaning that for every log line we sent, we had to establish that connection, close that, and it added a lot to request latency to clients. So when I started, we changed that to something like this. So we had an app, we had a framework we built which unified those log messages all to be in JSON and standardized, including some context. It did then send it out to standard output, and the whole thing was running in Docker, meaning that we just dumped all the logs to standard output, then picked it up with Docker log driver, and we had log stash deployed for every node, and then we just sent it to Elasticsearch and then looked through logs using Kibana. There were few good things about that system. So it was structured and it was really easy to search for interesting log lines in Kibana. It had a data structure which we were able to extend and keep up with, and we did know how to use that. It was also standardized on framework level, so it was very easy to use for engineers. Then we did have common tags, meaning that we could just extract, for example, user ID from the context of a request and inject it into a log line, or we could extract trace ID, or we could extract request or session ID and insert it into a log line. So that was really neat, and it allowed us to easily investigate problems. There were a couple of, well, trade-offs with that system. Because we didn't have that large team, we did have to compromise, and those 2 compromises were, one was we did heavily rely on Docker to deliver those logs, So log driver in Docker is, well, it's okay, but it's probably not something built for a large scale operations. So if you try to deliver, let's say, hundreds of thousands of lines of log messages per second through a Docker log driver, well, your system might end up not in a very good state. But we didn't have that scale, so it was fine for us at that time. And we also did not use any streaming or queuing for logs, but that again comes from that decision to use log driver. So on a system of larger scale, we prefer to use streaming, so either Kafka or Kinesis to deliver those logs or some kind of a queue. And we did also rely on Elastic Cloud to store our logs, but to be honest, I don't think that was that a bad decision. It was quite pricey, but it did remove operational overhead for the team to handle our own deployment of Elasticsearch. Well, and that's what I'm working with now. This is data platform at Skyscanner. This one handles both logs and metrics. So what we have here is, again, what we call MShell is a standardized framework across multiple programming languages. It has an SDK for something we call Grappler, which is a front end for our data platform. Maybe not front end. I'll think about the word. Can I write here? Edit. Oops. Okay. So, and then it hits HTTP API for Stripstream, which is again another front end for Kafka. So then all the logs are queued and then delivered to Elasticsearch. That's a very scalable system, which allows to consume hundreds of thousands of lines per second of log messages and more hundreds of thousands of lines of metrics. Well, so I won't probably come back to this diagram when I will talk about metrics. So covering metrics here is metrics are written through the same SDK and the same HTTP API into Kafka, but from Kafka they're consumed by Elasticsearch by OpenTSDB, which is then connected to Grafana for visualization and then to Boson to send alerts. So talking about logs, so what are the lessons learned specifically for logs? Well, first of all, structured logging is important. In the modern world, you might consider using protobuf to send log messages. If you run something less complex, then you might end up with just using JSON. There should be, though, some kind of a standard data structure you try to keep and to use it across all the programming languages and framework you work with. That would allow you then to consume and easily display and search through your log messages and your Kibana or whatever system you're using to look at your logs. And it would also allow you to perform some analysis on, on all the context information you send through. Then it is very important to also define standard tags for context. So you can send information like user ID, requests, sessions, traces, order IDs, payment IDs, anything you work with, any domain information which then can help you to easily find errors. Then login should be decoupled from the application, or at least it has to be asynchronous. This is very important because if you don't really decouple it, what may happen is that you try to send a log line, and at that very moment your container crashes. So it might not be even a problem of the application itself, but let's say your so out of memory, externally kills your container, and that's it. So you haven't sent that log line, and it might be important. And that means the next thing, which is reliable log delivery. So you should have some reliable transport platform to deliver those logs from your applications, containers, whatever, to your storage system. Because there might be cases where, well, you try to send it and service on the other end for some reason is not available or in maintenance mode, and that's it, you can't deliver the log line. So building that resiliency is important, although I must admit it comes with a larger scale and availability of engineering resource to build those resiliency systems. What I forgot on this slide is also don't send PII into logs, which is especially important if you use third-party logging systems like Elastic Cloud or Splunk. But even if you use AWS, it's still third-party. It's not in-house deployment in your data center. You're still sending personal data to third parties, and then you might end up in a situation where other engineers can see the data you send from your customers, and they not necessarily should have the access to that personal information due to GDPR. And that's also something to consider. You might have some automated sanitizers to remove personal information from logs, but it's cost factor to consider. Sorry, I'm just making notes just while I go. Then metrics. Well, this one is going to be short because I showed you what we have in Skyscanner at the moment. My previous platform went through 2 iterations actually 3. The third one happened after I left. So the first one was Graphite. Then we migrated to InfluxDB, and as far as I know, the company now uses Prometheus to collect metrics. In Skyscanner, it's OpenTSDB. I might ask what was before OpenTSDB, but I think it was also Graphite. It's an interesting one to consider. What you want? Do you want to use push or pull? InfluxDB seems to be quite a nice choice if you run Golang infrastructure and you're generally familiar with Go. InfluxDB might be a good choice, but it has some challenges when running at scale, and it might not be the best choice at scale. So Skyscanner, for that specific reason, runs OpenTSDB, but we are currently starting migration to Prometheus as well. Prometheus plus Thanos, probably Prometheus plus Thanos. And quite a lot of people think of metrics as just let's measure CPU memory and disk space, and that's what our metrics are. Those metrics, though, they are quite useless usually. They won't give you any operational uplift in what you do. You won't be able to investigate incidents. You might be able to, but that's only in a case where you run like a very low latency, high volume service with like thousands of requests per second, and their CPU might be important. If you see a spike, that means something is wrong. With most services for companies of medium scale, problem in your system won't be in any way reflected in CPU memory. And that means that you need to do 2 things. You need to define the standard around the metrics for typical operations like doing HTTP queries or database calls. So you record every HTTP query with its return code, or how many bytes you sent, or what else was there? Code, bytes, method, or endpoint, depending on the backend you're using for storing metrics. And based on that, for example, you can calculate your RPS. You can monitor error rate per second, like how many 500s you hit in a period of time, and that would give you a basis for alerting. Same goes for databases. If you start recording unsuccessful database calls, or maybe calls which are, for example, too long, it would work for you a lot easier than trying to just use something like slow queries in MySQL. It's not very efficient way of doing things. And one more thing here is to gather business metrics. So again, CPU memory is probably like hardware level, and you don't really care about that as an application engineer for like a typical service with not very high scale. And what you do really care about is whether your orders are coming through, or your transactions, or whatever your domain is. And if that fails, that's what you want to know about. Or if you look at, like, from front-end point of view, if you have a multi-step funnel making an order, you really want to know how many users drop out at each step. Yeah, you can do that via Google Analytics, but there are quite a few other ways of doing things, and there are quite a few different places where your system can fail. So gathering business metrics which will inform you on generally how your system is behaving every time your order is made. Like, can you have a metric on top of that? Can you see a drop of orders? Can you see a drop of number of orders in a specific region because there is a, I don't know, lightning hit in a data center and you don't know about that yet? Or there is a power cut? And can you see those type of things using your metrics? It's not something you can really get from CPU or memory. Well, you can if it's like a power cut and your servers are offline, you probably will. We'll see that drop in CPU, but again, if it's infrastructure, it might just be some time before those metrics reach you. And the last and the most important one, metrics have to be actionable. So whatever metric you define, whatever metric you rely on, whatever metric you show on your Grafana dashboard, this metric has to be actionable. And actionable in this case means that it has to have some threshold when it's, oh, what did I do? It has to have some threshold on, well, when it's not healthy, and it has to have an associated runbook. Okay, sorry, it has to have a threshold when it's unhealthy. It has to have an alert to inform someone if it's important enough to be actioned upon overnight. And then it has to have an alert, a runbook to perform some actions to mitigate the problem. One more small thing here is probably don't deploy anything overnight. It's not really a good idea. Even if you're one-man band and you do everything alone and you think that you know your system like super well, still that the ideal way of mitigation is to fix it so it can barely work till morning, and then when everyone is in the office, then fix that permanently. Then the last one is tracing. Well, to be honest, it's not that widely popular still, although it's not less efficient than metrics or logs, especially because it combines two in quite a lot of ways. Well, tracing is essentially for you as a user of the system is this nice picture where you can see all your microservices for every call you make, talking to each other, how much time it takes, and whether there are any problems associated with that. So there are quite a few additional benefits and ways to investigate problems with your services using tracing, like network-related issues or API calls latency or internal language latency. For example, on this service diagram on the right, you can see those large yellow circles. This is a way of a system here, which is called Lightstep, to show you that those services contribute to latency of the whole request more than others. And those services you might want to investigate to see if there is anything going wrong there. You can also use tracing to investigate problems with thread or Go routines. I had a case in my practice once where one of our services was leaking Go routines, and tracing really helped us to actually nail down and understand what's wrong, just because we had that information traced and we could see that, you know, this generates a lot of traces. Then, okay, I will just a bit refactor that slide to bottom. Then there is dependency analysis and service diagrams you can use that for, and that's again this is this service diagram here, so you can see which other services called your service, and you can see the whole picture of your whole microservice stack in one go without trying to do that manually. And you can also use tracing to as a structured login platform. So you can record logs here, but the thing about that is that logs will be associated with every operation you make in tracing. So this one, for example, is a transaction to charge customer credit card, and it generates some log with payload sent to a server. And here you can easily see that log information associated with this specific operation, like in comparison to, let's say, the way you usually look at logs in Kibana would be, you'd see like the whole data flow unstructured, not like a tree here. You're going to see all of that, and you will see those log lines. You'll have to carefully look into them to understand like what the payload is. Here it's a lot well presented for you. And there are also tags. It's in the top right corner here. Again, the same standard tags you might want to consider for logs. You might reuse the same tags for tracing, so you can then cross-reference those. And again, for metrics, you can use the same set of tags again. So then you can easily jump using this workflow links feature here. You can jump from, let's say, tracing to logs or metrics and use that all together. UX error exceptions, crashes, structured log. Yeah, that's fine. Most important thing about tracing is that it might be used across multiple transports. So by default, there are like two very much common use cases here. One is HTTP and one is gRPC. So services communicating using these protocols will automatically be displayed in your tracer, and you'd be able to see those services communicating to each other. But if you use something not that straightforward, like you use queues, for example, like SQS, or use streams like Kafka or Kinesis to communicate between services, what you can do is, well, you can cover those transport with custom tracing calls and track those as well. Well, for message queues, for example, every trace, so every picture like this has its own identifier, which you can actually see right here, right bottom corner. It's called trace ID. So it has this ID which you can pass in SQS messages, let's say next to your payload, and on the other end, on the receiving end, you can then reconstruct that trace using that ID and continue your trace. So the whole picture of how your request was processed asynchronously can be maintained. Same goes for streams like Kafka or Kinesis. Again, you can automate database calls. You can automate calls to caches, or you can even do things like tracking email delivery. For example, if you use Amazon SES to send emails, you can embed again trace ID into header of your email, and when you receive a webhook about email delivery notification, you can restore the trace to display that information in your trace. That's a lot of work to automate all of this, but again, this improves overall observability of your system, so you know what's happening, why it's happening, and you can investigate easily. Well, my personal record so far is automation of like stacks, both at Currency Solutions and now at Skyscanner. And the longest trace I had so far was covering 20 plus services with like 1,000 spans. So it's roughly like 50 spans per service just in a single trace. So I first started working with distributed tracing specifically, well, in 2016. I need to find out the exact number. I think it was 16 or 17. It's probably 17. Just a sec. And for the whole observability, these are the lessons that I learned so far. First of all, define standards, because standards will help you being consistent. They should include your data structure for logs, like I showed before. They should include command tags for logs and traces, and your requirements for ideally not storing personally identifiable information in your logs. Then, then when you define a standard, it has to be practical. So you have to do a research to make sure that all your languages can support your plan to include some sort of automation. And it's very important for support of your standard to be consistent across languages. So if you thought about some super cool feature, but only one language can support that, consider actually removing that to maintain consistent experience for all engineers across different stacks. Then there is the hardest one: sell those standards. If you have, well, just 1 or 2 or 3 teams, that might be easy. But if you have 10 or more teams, that might be not that easy. So when introducing at later stages, well, when you have like lots of teams and lots of services, imagine that 50, and you have a lot of teams working on those services, it may not be that easy for teams to accept that new thing you're trying to add and to incorporate that. That, to be honest, goes for all migrations you do, whether you're migrating from OpenTXDB to Prometheus or from Graphite to InfluxDB, whether you're migrating from one tracing implementation to the other, whether you are changing your login system from, I don't know, Elasticsearch to Loki. Selling those to your teams, well, it comes at cost. So it's very important to actually be ready for this to be quite a long work. Then one more is abstraction. In my both experiences implementing observability, we actually had abstractions built, because building a standard is one thing, and that usually exists like as a, I don't know, Confluence page. But making this standard practical means that somebody has to implement that standard. And it's one thing where you can build an abstraction and provide that abstraction to your teams, and they have just add that framework to their code, and it's just going to work like magic. Or it's a very different thing when you drop them a Confluence doc and ask them to build it for themselves. Obviously, it's going to make it inconsistent, because everything will, let's say, every team will interpret standard in a very different way. And then it's very important to track the adoption. So once you install the standards, you agreed that you're going to build an abstraction, you build that abstraction, you had a meeting, you told everyone, okay, we're going to build that. Everyone says, yeah, we're happy, we're going to build it. It's very important to track where you are, how the migration is going, and what the problems are and blockers are, especially if you have, let's say, lots of teams and services, and you're finding problems in your abstraction, in your framework, and you have to update that. Then you have to keep up with all the version changes across all the services. And metrics are going to help you here. So treat your adoption metrics of your framework as any other metric or business metric. Emit those from your abstraction or your framework and track that. So build dashboards for yourself, and then you can see that, you know, that team and that service uses this version, that version, and that team is fully migrated, and that one not really, you know. And that will give you some full picture at a glance, and that's really important, because otherwise you're just going to get drowned with, you know, that tracking and chasing people. Well, and it's very important to try to do it better next time. And this usually means I forgot what I meant by this one. Okay, I remember. I'll come back to this one on do better next time. And there was one more thing, sorry, here. On transports, I need to add a slide if it's not across transports, they're going to be one big slide with a black hole. Because when you do multi-transport and you don't have that consistent environment, so you use HTTP and queues, for example, you do on HTTP, but you don't do queues. What you're going to end up with, you're like 3 services talking to through HTTP are going to be displayed in a trace. Then you drop a message into queue, you receive it on the other end, and you start a brand new trace because your trace ID is not propagated. So that means that, well, this whole kind of observability actually, well, doesn't work. And that's why you need to build that support to support your transports, especially if it's like a, let's say, request transport. So not just observing a database call, but actually transferring a request to another system to process. That's it. Thank you.
Cool. Awesome. It was really good. I don't really have any suggestions to improve. I have some questions, and you might or might not decide to include this information in your presentation. I think there are. This is I don't know how to say this. I think a lot of companies need to have this, and they don't realize how important it is. I think you mentioned that in your presentation as well.
Yeah.
We actually, in our company, we are in the process of introducing this sort of things. I was wondering how you, like, do you work, do you have, how do you get people to do this, right? Because
oh.
So do you, and actually, how do you structure teams as well? Like, because I think there are different ways of doing this. One is like you do it with them or for them every time there is a new standard, or you. This is what we're thinking of doing, is to make it so good. Like, we don't actually want to enforce it. It's like, if you don't want to do it, don't do it. Because other squads are autonomous, right? So if something goes down, it's up to them. Like, if it goes down, it's their responsibility. It's not like I am responsible for them, which means that we can provide very, very good tools for them, and it's their choice whether they want to use them or not. If they don't and want to do their own thing, great. If they don't and they just don't have it, it's their responsibility, which means if the website goes down, then they don't have the tools. But basically, our idea is just do it so well and so easy to do that people will just adopt it because it's just easier that way. But there are so many different kind of school of camps to do this sort of stuff. I wonder how you do it, guys.
Before I start, are we going to record the meetup, the talk?
I don't think so.
I mean, it's good because I mean, if it's not recorded, I can just give more details than if it's recorded. So first of all, I have 2 experiences. Yeah, so in the previous company, it was smallish. We had less than 20 people, and that was still selling. I did not enforce it, and we did it gradually over a year. But we did have 1, 2, 3, 4 programming languages. So we did have to build 4 different abstractions for 4 languages for like 4 different generations of services, including PHP, and that was tough.
That's not fun, is it?
But it's not fun, but we build it, and that 1,000 spans across 20 services is not Skyscanner. It's my previous company where there was a huge PHP monolith in the middle. So that's a cool thing. And so in previous one, so I had to sell it, and then what we did, we built abstractions, and then there was one person doing that routinely. Like, they had that like time allocated to improve that. But generally, we had an ask for people to gradually improve that, and that's why it took us so long. But we did, again, also we didn't want to force it. It was quite quickly when people, so here is like full end-to-end everything. So the first benefits we started to see like a month-ish after, maybe 2. Okay, 2 probably, because one month is like from the very beginning of the project. So when they started seeing like benefits that they can go there and investigate problem faster than looking through logs, then it just started working like magic. They actually were really bought into to improve that. In Skyscanner, that's a very different story, because I have 11 engineering teams myself. There are 4 principal engineers for 11 engineering teams. My like my focus is, and we are split in like what we focus on. Some like I have a few things in my work where I focus like narrowly on like 2 or 3 teams. I have larger things like tracing, for example, where I work on the whole tribe, all 11 teams to implement that. And I have to sell, so it's a really hard sell. I have to talk to them, explain to them why, show them through Lightstep, and explain to them that this is like why it helps you. Find good examples of how other teams do this, and show that this is what you're gonna get if you implement it like this. And then what we did, and then there were 2 major kind of, how do you call this, like a not a pivot point, but like in inflection point, yeah. So generally something where we started changing faster. So what happened was, we have operational meetings where we run like how do we operate as an engineering function. So generally we review like metrics, I don't know, security issues, performance problems, SLOs, something like that. And in that meeting, I got everyone to agree that we are at the stage where we probably want to implement it like end to end. Otherwise, it's not getting very useful for teams who have it enabled. That's what the buy-in. And then it took me up to several months to find actually, again, one person, but who's going to drive engineering implementation in the tribe. What's important is that Skyscanner has that abstraction. Yes, Skyscanner has actually the tooling and the framework which has tracing enabled. So it just comes to enabling that in those services, adding like custom instrumentation like tags in places where needed. Then there is a wider piece of naming convention. For example, we have our stack, and we say that we have like something called, let's say a payment ID. And we want that payment ID to be called like this as a tag. But then we have upstream and downstream services within Skyscanner which also use payments. So for example, we receive payment information from one service out of our stack, and then we send it to another service out of our stack. And this is the same payment ID we pass through. So there is a huge alignment problem. It's not a problem, it's a hard problem to solve. How do we align on naming conventions for that specific tag name? It's like a small thing, yeah, but I want it to be the same across the company. So when I search for something, I can use just one name and be sure that this is the same name across the company. So it's really its influence. It's like talking to people, talking more, and then showing them, selling them. It's endless loop.
I find that could be a talk in itself. Because it's true, like you can do it for like 2 services that you own, and that's pretty straightforward. But then if you have a company of like 100 engineers, that's your challenge. Like, how do you get people to adopt it? I think it's harder than the technical side of things.
Skyscanner has like hundreds. Yeah. It's gonna turn over 1,000 in I'm not sure next year, but in a couple of years, I'm pretty sure it's gonna.
Yeah. I just realized that last year in the February meetup was also at a Telegraph, and also had a speaker from Skyscanner.
Oh, really? Who was it? Not Nicky?
Samuel Stradling.
Oh, Sam, he's the one doing the tracing work for me.
Really?
Sam is doing that.
API gateways last year.
Yeah, so Sam took that tracing work hands-on for me. He's in my tribe, and he's in one of the teams doing they're doing the app and BFF for the app for the part of the business I'm in. So yeah, Sam is literally the person who's doing that. And Nikki Wrightson was also at your meetup one day. As no, I think she wants to come to my talk as well. Not sure if she will. But she wants to.
Cool. That's great. I think it will teach a lot to a lot of people.
Let's hope.
And no, it will. And it's the kind of things that are perfect for this meetup. So I look forward to you presenting it to everybody.
Cool. Thanks. So let me probably. I'm not sure. There are 2. I mean, ideally, we would rather just do another call for like 20-ish minutes closer to the date, maybe like 10th of February or something. Yeah. So just give me 10 days to finalize the visuals so it like looks good, and then I'll just go through slides, just reminding you what the slide is about, and that's it. And I'm not gonna do the talk, so I'm just gonna run it through the deck.
Yeah. Can you do the Thursday just before, like 13th?
So, just a second. Thursday, 13th. Just bear with me. Outlook. Hey, Outlook. 13th. I can same time.
Same time.
Yep.
Cool.
One or maybe half one, even better.
Half one, okay. Cool. Just send the invite now.
Thank you. So let's book it just for half an hour, and yeah.
Oh yeah, I put 45 minutes. I can make half an hour.
That's fine.
Cool. All right.
Cool. Thank you very
Talk to you
much
then.
for your time.
And in the meantime, if you have any questions or you want to send over some drafts or like anything, literally anything, just ping me and I'll reply to you.
Okay, cool. Do you know the setup of the Telegraph? Will I have most important the presenter screen?
There are, well, I mean, last year, and I think it will be the same this year. There are two big TVs, one on each side, and then there isn't a TV for the presenter. You could use your laptop.
It's not. I mean, if you walk and talk, it doesn't
Right,
really work.
I see. No, I don't think there is a TV for the presenter. No.
Okay, I might use the laptop. Yeah, I'll see. Yeah, cool. I mean, there are some notes. I just use them sometimes. Like if I feel that there is something important, I use it. But yeah, whatever. Cool. Thank you very much.
Okay. See ya. Bye.
Thanks. Bye.
Vai, 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 vai. No, oggi devo cucinare, dai.